How was the conference?
It was good. I am excited to show you guys just like a few.
You got some merch? You got some?
Yeah, the Jupyter shirt. Yeah, there's some really cool stuff going on in the community. The conference itself was, like, well, there were 2 days of conference, and then there were 2 days of tutorials and workshops before. So I went to 1 day of workshops. The first one I did was on deploying your own Jupyter Hub, which was really neat. We actually worked through, like, step-by-step how to set up Jupyter Hub on Google Compute, like on the Google Cloud.
Can you remind what the Jupyter Hub is compared to Azure, things like this?
Sure. So Jupyter Hub is it's a multi-user interface to Jupyter, basically. So you can have multiple users who actually spin up Jupyter notebooks or Jupyter Lab or whatever the instance is on the cloud, or it can be like a single server or something like that. But it is like you have a centralized point that you're logging into as a user, and then you can access Jupyter from there. So when you're looking at things like UBC's syzygy, that is a Jupyter Hub deployment. When you look at like my binder, that's a more complicated something that's similar to a Jupyter Hub deployment. And then things like what people are doing for Berkeley for the data courses. Each one of those courses has a Jupyter Hub deployment.
So you're handling all the libraries, they're all installed on your instance, and then
yeah, so you can set it up so that you basically like pull a Docker image basically of whatever libraries that you want, and then you make that available to all users. And then they can also install stuff on their own like user account, and you can configure who's allowed to do what and all of those kinds of things. But what's nice about this is like if we wanted to down the road host examples that are too big but we want them to be live, like we could actually deploy our own Jupyter Hub on Google or similar. Google's the easiest, and have people running on that.
Store files and.
Yeah. So I'll show you actually. So it's there's 2 styles of tutorials that they've done. I'm just going to share my screen. Hey, Joe.
Hi.
We're just catching up on JupyterCon and interesting things with that. So there's 2 sets of tutorials that the Jupyter teams developed on like how to deploy your own Jupyter Hub. There's 0 to Jupyter Hub, and so this is meant to be deployed on a cloud. And they're using this package called Kubernetes, which is actually super cool. It basically lets you sort of set up and partition resources. So for example, if I set up a Jupyter Hub for the SimPEG team, and we wanted to make sure that everybody has at least a gig of RAM, and we're going to cap it at 8 gigs of RAM so that our Google Compute doesn't go. You can configure all of those kinds of things with Kubernetes. So it basically sort of like you allocate resources, and then Kubernetes takes whatever hardware you have and then is an interface layer that sets that up and partitions it reasonably. So sort of like a virtual interface to your hardware. Does that make sense? Yeah, that's kind of like weird conceptually, but it's super powerful. And so this has basically everything you need if you want to set up a Google Cloud or other. I guess they've got them for most of the cloud providers, all the big cloud providers. And then you can also set this up on your own hardware, but that's something I'm not familiar with how to do. You have to have Kubernetes and all of that installed. I mean, that's what this is built on. The other one that they have info on is called the Littlest Jupyter Hub. And this is for smaller deployments. And it's basically meant to be like if you have a single server. So the 0 to Jupyter Hub is for if you're on a cloud and you've got access to cloud resources. This is for a single server, like smaller Jupyter Hub. So if you're not doing, I mean, if we just had 6 users and nobody's doing anything super large, then that's sort of a good place to go. So that, like, if all fell apart, Doug, with the UBC stuff for 350, like this actually is not a hard option. It should definitely be a backup. Like ideally you're on the UBC stuff and somebody else is doing the maintenance for you, but it's good. Yeah, good to know that that's out there.
Yeah.
Yeah, so it was pretty cool. We actually went in like a 4-hour morning, starting from nothing, deployed the Jupyter Hub, and then hooked it up to my personal website and linked HTTPS, and like I was able to log into it and install SimPEG. So it was pretty cool. Cool.
How much resources do Google gives you?
Google will give you, I think it's like $200 to $300 for free to get started.
What do you mean?
Compute.
Oh, okay. They still charge you on the hood. I see.
Yeah. But then you can scale up quite large. So they've got I think they had there was a page on basically like sort of what you expect to pay. The cost calculator.
Yeah.
So you can actually have a look at different, like the Google Cloud pricing page. And so depending on like what machine you spin up depends on the cost. So like if you wanted to do a crazy large inversion, you can get ginormous machines. That's really doable. So, and one of the things that I'm really excited about that Eric, one of the developers who's actually in Sweden, has been working on is getting auto scaling in place. So right now, if we set up a Jupyter Hub and you allocate resources, they're allocated so that they're sort of always running. So even if no one's actually using the 1 gig, like if we get an N1 standard, if nobody's actually using it, it's still, we've reserved it. But he's working on getting auto scaling in place so that if nobody's using it, we just turn it off. Yeah. And then if somebody comes on, you turn it back on. So that'll actually start making it a lot more tractable.
Mm-hmm. Yeah. What are the two prices? One is kind of like a spot price. Is that the preemptible?
I have no idea.
Yeah, that's hourly. Sweet. How much is the monthly? Can you switch on top? There's a flicker. Yeah. $50 a month. 2 CPUs. All right.
Yeah.
It's not bad.
And then it depends on where you are too. I think, or where you spin up the machine. I don't think they're like drastically different, but they are.
$100.
So. Yeah, so that was kind of neat. Cool. Then there was, I think at some point most of the talks will be posted. I don't know. Last year they were really delayed in getting them out, so I'll try and keep an eye out for them and let you know.
Perfect.
There are a few other just like interesting things that I thought of the SimPEG community in general, just with packages coming up or with different projects and things like that. Just trying to figure out where to start. Let's start with the widgets and with IPy Leaflet. I don't know if has anybody seen this before? It lets you bring in leaflet maps right into the notebook, which is pretty slick. And you can add layers in basically any like public data set they've got good interfaces to. So, because Dom, I know you were doing some work getting stuff reading into Google, and I actually think that this might be way easier.
Put TIFFs in, yeah.
Yeah. And so, like, they've spent a lot of time working on this. So he's got like split maps. If you want a data set on one side, you can scroll and
Can they switch to the pictures though, or it's just the maps?
What do you mean?
Like the Google.
Oh yeah, yeah.
Images.
So here is their docs. So I think.
Yeah. Okay.
So that's one that was pulled from NASA. But you can definitely switch to like a Landsat view for sure. And then you can add markers and things like that, and polygons and layers.
Okay.
And the markers, what's actually really cool about some of the polygons and layers is you can treat them as widgets. So here they've set draggable as false. So if I move this map around or like try and grab the marker, that doesn't do anything. But if this was set to true, I could pick it up and move it. And then when you treat it as a widget, like it is here, then you can actually access like the location and its information like in the next cell.
That's way better.
So yeah, so I think this is stuff that we should be looking.
Do you know how that interface with other like plotting library like Matplotlib, etc.? Because I don't remember if I played with IPyLeaflet especially, but I remember at some point I tried a few to load the OpenStreetMap or Google Map into the notebook, and I succeeded to that with several of them. But for a lot of them, my difficulty was actually to cross that with all the plot that I wanted to make on top. And it was not always easy, so.
I don't.
Okay.
Yeah.
Looks like you would have to use their
own interface.
Yeah.
Although I wouldn't be surprised if you can, like,
output an image and
yeah, an overlay or something like that. I'm sure that like there's somebody out there who's figured out how to get Matplotlib talking to this. So yeah, so poke around in the docs. There's examples, and that's pretty neat.
Do you know what you can trace? Can you like click a polygon to it?
Yeah.
Perfect.
Yeah. I know that Sylvan's given a few talks on IPyLeaflet, so I'm pretty sure if you just Google him, you should be able to find some. I think there's actually also, Carol got me onto this, it's PyVideos, I think. Yeah, so PyVideo has all of the Python, PyData, SciPy talks. So that's one place you can go to actually go find all of these things. So.
Lindsay, back to your other thing. So if you're doing something that's completely mundane, but does come up. So let's suppose that we wanted to book a place on, through Airbnb and also use Google Maps and just have them kind of located so you could have them talk to each other and you could maneuver them a bit. Would this help?
If you can connect to the
not necessarily for an Airbnb case, potentially. Like in that case, just using Google Maps is just as easy. But here, I think if you have like any sort of data, so like what Don was saying, if he wants to click and draw a polygon, for example, on the map and then get his points programmatically, all of that is stored as a widget, so he can access them in the same notebook.
Okay.
when we're doing targeting, Doug, based on 2D maps, that would be perfect, because then now the users can just click in a notebook and export that to some other software, because now we would have the overlay of geography and geophysics or whatever.
Okay. Yeah.
That makes a lot of sense.
Yeah, and they've done a nice job plugging this both into the notebook and into Lab.
Those slide maps are sweet too, eh?
Yeah, that's pretty slick.
Because we could do 2 overlays and then just swap between the two.
Oh, wow. Yeah, that would be really cool.
Yeah, data and some transform whatever. And just
Yeah.
Ooh.
Total mind gradient.
Yeah, so
Whatever,
and too, you can
mix
do,
them in.
like, they've got vector plots and things like that
Mhm.
on here. So like, I think this is definitely what we should be using for map style stuff.
Totally. Yeah.
Um,
I'll look into it.
yeah. I think that's it. That's it. That's it. Oh yeah, Jupyter Lab. Jupyter Lab is now like actually pretty ready for use. I was playing around with it while there, because there were a lot of things before that, they just hadn't matured and like figured out little bugs. Now it's actually pretty stable for use. And so actually, if you're on any notebook, so here, let me see, that's, we'll come back to this. But if you just launch a notebook, normally it goes to tree. So your URL, let me show. So here it goes to tree. If you launch like Jupyter Notebook, you can just swap that to lab. And I need to build the leaflet because I was poking around with that. But then you can start playing around with Jupyter Lab. One of the things that like a lot of people have found just extremely beneficial right away is the file system is better. So like I can drag and drop, move things around. So rather than having to rename the notebook to include the file path or whatever. So those are some simple things. You can see what's running, get commands. And then they've got like markdown editors and things like that where you can actually look both at the markdown raw and then with the preview as well, which is pretty slick. So I can look like as I am editing, it should update. So that's helpful for just like, updating your simple markdown files. There's also some really cool things where you can attach a kernel to your markdown and run your code samples to make sure that if you like created an example that it runs. I don't remember how to do that offhand, but there's docs on that. Cool. Okay. So the other things that were kind of neat, Google Earth Engine is like basically a lot of an extension to Google Earth, but here they actually have, you can access all the NASA data sets. They've been working on like getting that API right with them so that you can access any type of data. They showed sort of using it in Jupyter. And right now, to get access to the API, you do need to request access, filling out the form, but I'm pretty sure anybody here who says they're doing a graduate degree in earth science should be able to get it.
Super easy. I requested one for free and I got it.
Yeah.
Except.
Yeah, so like they've got different time-lapse data sets and interesting things like that that you can access. So this is kind of neat. Cool. Okay, then the next thing, which order of operations? I'll show you IPy volume, and then I will show you some of the stuff in Pangeo. So IPy volume, I think we chatted about this probably at some point. But I got connected with Martin, who is like the main developer of IPy volume, and he's made a lot of progress in the last year. So I chatted with him last year and then again this year, just of like where things are at. And so they do like volume rendering in 3D.
Nice.
So he's got things like quiver plots, but one of the biggest, and I don't think this example will be here yet, But he's now got volume rendering of multiple objects in there, which is fantastic. So that if you want to have multiple data sets or like surfaces plus your inversion results and all of that, that is actually possible. One of the things that he doesn't have, but he sort of trivially has, so this would be a very easy thing for us to contribute, is slicing. So right now, like the bounding box is sort of the slicer. So if you move the bounding box relative to the object, it'll slice through it, but that's not as intuitive necessarily as having a slicer. He's got ISO surfaces, all of that sort of stuff. So I think that this is worth like hitting on and playing with for looking at 3D results.
Should I be detailed at any step, or is it a complete different library?
I don't think so. Yeah, I don't think so. So.
Yeah, I wonder what he uses in the back.
No, eh?
Yeah.
I think he wrote most of it.
Sorry?
I think he wrote.
Just OpenGL just went right in or something, or can you? I haven't really seen much Python.
Py3.js, I think, is what.
Huh.
Yeah, so it's all with Py3.js.
He built that up. Good for him.
Yeah.
Jeez. I like dabbled in making that stuff, and I was like, no. It'll take a while.
Yeah. So that's pretty slick, and I think he's very responsive too. So if we start poking around and making it useful, and especially if there's things that we can jump in and help out, like slicing, that's actually pretty easy. I think he'd be quite receptive to that. And he showed me there's, so I think it's here. He's got some good tutorials that actually sort of give you an idea of how volume rendering is done. Because there's things like, let's see, sorry. Sorry, so ISO surfaces are actually very expensive to compute, but there's ways to sort of hack around that just by setting reasonable ranges and opacity on things that get you close enough to your true ISO surface. So those are things that you can play around with, but ISO surfacing is actually in there. So, yeah. So that's pretty cool.
Is there any output, like, does he have outputs of certain types? Say, do you want to output it like an ISO surface or something?
I don't know.
Oh,
I haven't looked into it yet, but I'm sure there's a way to access it.
Yeah.
At some point.
Well, it looks like he's using the try-surf function, so it's just nodes and connectors.
Oh, okay.
Yeah.
Two arrays. Yeah. Then you can, I guess, convert it to whatever you want.
Yeah.
Nice. Oh, that's cool.
Yeah, so it's pretty neat. And I think like we actually could be one of like the user groups that really helps push this package along, which would be it would be great to see actual like decent 3D visualization that's open source.
Yeah, it looks like it's points mostly right now. Is that the?
But he does have volumes. So the example that he showed, I don't know if it's.
Did you see that one looked cloudy?
Yeah,
something
like center.
There's one demo that they did. When did this update? No. Anyways, there was a demo that he did of like structure of a brain and a head. So he had each colored differently, and you could see that was actually like a volume octave model. And he's done some clever things too, so that you can effectively resample as it scrolls, as you zoom in. So for example, if we have a very large mesh, you don't actually want to render the entire thing. So you can define based on which scale you're on how to draw the image.
Cool.
So like he knows what he's doing.
Yeah, there's some good work in there.
Yeah.
Very good work.
So that's totally worth checking out and playing around with. Actually, one of the things that we could maybe do is start like a Scratchpad repo in SimPEG and just put notebooks of like things that you've tried that are interesting. So if somebody starts poking around with IPyVolume and is like, here's a decent example that uses SimPEG, there would just be a place to put those kinds of things. Would that be useful? Yeah.
Yeah, why not? Yeah.
Yeah, I mean, obviously for us, if we can get the tree meshes to display, that's going to be kind of critical.
Yeah, I mean, we'll have to resample them onto a regular grid. I believe that most of his stuff uses a regular grid, but that's fine. Drawing or resampling, like a reasonable resampling should not be hard.
And if he does a trick of changing the resolution in terms of as you zoom in and zoom out, might be able to make it cheaper.
Yeah, we might have to implement that piece
Okay.
or like give the instructions, but he has examples of how to do it.
Great finds.
Yeah. And then the last thing that I wanted to show for now is Pangeo. This is related, I guess, actually. So let's go to pangeo.pydata.org. If you go there right now, you'll be asked to sign up, but because I've already signed up, I can log in automatically. So they've deployed a Jupyter Hub for geoscience specific use cases. So like what comes predefined in the image is they've got a lot of the standard geoscience packages loaded in. And so they've got a few examples, and this one is actually super cool because they're using Dask and Xarray. So Dask does parallelization, and Xarray is like smart storage of structured data. And so if we go through this, so those are both packages we need to look into for SimPEG and for processing, actually. I think Xarray in particular might be exceptionally powerful there because it is, it does like lazy computation of like matrix operations. So if you define like your set of operations that need to be done, it's not actually going to execute until you call for the result. Does that make sense?
Yeah.
So like in SimPEG, if you're doing computing the fields, for example, right now, if you actually use NumPy to do that, it's going to compute at every single step.
And then store it.
Right.
Yeah.
Xarray stores the set of instructions and then does a little bit of optimization if it can across these set of operations that are being done.
That's pretty cool.
So that's pretty cool.
And this is all in Pangeo, is it?
Yeah, yeah, they've got some good examples there. So this example, we're doing sea surface altimetry data. So I think that this is like, this should show, that's what these are. So the first thing that they do is actually grab the initial data set, and we'll come back to the storage side of things. That's kind of interesting. I haven't had time to really dig into it, but we'll chat about it. So here they're grabbing the metadata, looking at what do we actually have in our data set. And then this is really neat, is here we're actually creating a Kubernetes cluster. So when I mentioned Kubernetes before, it is basically that like virtual interface to creating a cluster on any hardware. So here we've created a Kubernetes cluster with 20 workers. And you can go in and change, like do adaptive and manual scaling. But what's one of the really cool things here is then with Dask, which is doing all the parallelization and such, you get a dashboard that they've created that actually just tells you what's going on in your notebook. So here, I'm just going to rearrange some things so we can see it all. Okay, so right now we've got 1 worker, 2 cores, and 6 gigs of memory. So we're going to go ahead and plot the data. And so you can see right now it's processing, doing the plotting. And where are these? And now we see our plot. So there's nothing else going on in the processing. So the next thing we're going to do is take time series means over this data set. So this is going to be a computationally intensive step just because we're going through a very large data set. And so here, as soon as you start that, we then actually start getting an idea of what's going on. So Z-array is actually, we're paying our database, is the ZAR. Mean chunk, we are chunking the data, and then here we're aggregating or taking the average. And so you can see things happening in parallel as it's operating. And so we can have a look at what the workers are doing. I don't entirely, I haven't actually, if you ask me what these things actually are telling you, I don't entirely know. Tasks, we saw that, and then you can look at the system so we can see what our CPU, memory use, bandwidth, all of those kinds of things are doing. And then this, I believe, is telling you sort of the aggregate story of what's going on. So it tells you which file name we're accessing, for example, so that's purple, how long it took. That is the operation read into. So you can get a bit of an idea of just what's going on under the hood with this.
It's great to find bottlenecks.
Yeah, absolutely. So this is still going to take another minute or two. But there's some really good stuff in the Pangeo. Oh, now it's really scaling up. So we must have, there's probably somebody else on there before, and now they're not, so we've taken over more nodes, which is kind of cool. Yeah, and so I think that just reading a few things that they are up to will be quite valuable for us. I posted a link on Slack earlier just on data types in the cloud, because this is one of the things that Ryan Abernathy, who's one of the core developers of Pangeo, spent some time talking about, and spent time talking about in his keynote, was data types. Sorry, so I'll flip back to this so you can see the plot. So that's like that very iconic, one of the iconic graphs of sea level, sea surface height. So that's pretty cool. So one of the things that he was talking a lot about is actually cloud storage of data. Because now NASA and a lot of these big agencies are now producing petabytes of data on a regular basis. And accessing that is non-trivial. There's a bit of a shift away from what they call blocked data storage. So something like HDF, where you basically chunk up your data, but then to access any piece of it, you have to download the entire thing, and then you can query it. Because that's just less tractable programmatically once you start getting to these terabyte scales, where maybe I want one piece from this chunk, one piece from this chunk, but in order to access that, I have to download the entire data sets. So they're starting to advocate for more object-based storage, which is easier to query from the outside, so that you can access just the subset of what you need without downloading the entire thing. So there's a blog article that I posted that just gives a bit of an overview of what tabular, sort of some of the data terminology, because this was something that I heard a lot of terms being thrown around and just am not familiar with what's going on. So there's a couple file formats that I think are worth looking into. This isn't like a huge concern for us yet because our data sets are still small compared to what like NASA deals with. But I think it's good to stay aware of. So, because one of the ones that I think is quite relevant to us potentially in the future is ZAR, and that is sort of, I think they're trying to market themselves as the cloud equivalent of HDF5 or a cloud alternative maybe. And so that's talked a bit about in here, and then if you Google it, you can get a bit of an idea of just like how it operates, and it's interoperable with NumPy and all that sort of stuff. So.
And where does Panda fits in all this? Because it's also a data management API, right?
Yes, but Pandas is more so for tabular data. So ZAR is for like n-dimensional arrays. There's another one that is called, sorry, I wrote it down. It's Parquet, I think. And so this is looking more at tabular data, and it interoperates with Pandas. So I believe that actually, yeah, it looks like you can basically just read in and write out Parquet and Pandas data frames pretty easily. So.
All the creatures of the ecosystem.
Yes.
Some of them will survive, some of them will perish.
It's true. Cool. Let me stop sharing my screen. Yeah, so that's like a quick overview and smattering of things.
Thanks for distilling. Highly flat, definitely look into it.
Yeah. Yeah, and then how were, I missed the meeting last week and I didn't see if that.
Yeah, we did not kind of cancel that.
Okay.
It was just three or four of us.
Yeah.
We don't vote for us on the board about
We debated this.
how to compute the gradient and the smooth system.
Oh, yeah, it's simple versus very simple versus sticking on the bed. That was it.
Cool.
What was I going to say? Discretize on Redux. The wheels are breaking. The wheels are coming off the cart.
I know. What's going on?
Well, the build brakes on the wheels of Discretize if you use Conda.
If you use Conda?
Yeah.
Conda or Pip?
I need to use Conda because I'm relying on NB convert. Sorry, NB Sphinx.
Okay.
Which needs to be installed on Conda, and if I switch Conda to build a site, then it chokes on Discretize. I don't know if there is a way to build wheels specifically for Redux.
Oh, so it's on Linux that's.
I'll send you the. If you have time this today or
if I should do like Conda, so Discretize.
It just tried to build all the requirements for the site.
Okay.
And one of them is SimPEG, and when it starts building SimPEG, it gets Discretize, and then it just dies in Discretize. Basically, it's just have to look into it when you have time.
If Joe, you might be able to jump in here too. Maybe Dom, if you can post it on the Discretize channel in Slack, and we can try and sort out what's going on there. Because Linux generally isn't the one causing problems, so that's something we should definitely figure out.
Yeah, totally.
Any other things that people want to go over?
Just a thought for now, but it might be repeat. Like, I think it's worth that we start thinking of it and maybe in the next meeting. But how we do pull requests in SimPEG, because like one is already has been already away for a while. Soggy and you are going away in a very near future, and we're gonna have some control graduate also in the last. But even like, and so like if we want it to still happening extra, we might need to think of how we will do that, because I feel that even now that we are almost all here and interacting, we're all busy, but we're still gonna be busy in the future and gonna be probably worse. But so, like I feel that when there are pull requests, there are several people working on things that are going very smoothly. But as soon as there is a pull request that's only concerning one person because of their own thing, it's like, oh, I'm using this tool and nobody else is doing it. Feels like they can wait for quite a while and wait for reviews, or like a student look at review for a long time and just stay over time.
Yeah.
So like that might be something that we need to think of on how we can manage that, makes it easier or makes the pull request process quicker.
Yeah.
Yep. Somebody mentioned that it's smart to make these pull requests reasonably small. That was one thing that helped, because when you start making it really big and complicated, you work on something for months and try and bring it in, kind of what I did. It's a lot more challenging. It's a lot more to review. So that's one.
But sometimes small one even stays, unfortunately. So it's all about also like people giving time for that, etc.
Yeah, it's manpower.
Yeah.
Yeah, and then I think to your point about like being remote, that's then too where issues are going to become more important.
Mm-hmm.
And we need to go through and just like clean out, because there's some issues that are just out of date or like not a priority. Because then at least if we know like what people are working on, then hopefully we can make sure that there is less conflict or things like that do arise.
Yeah.
Yeah, I agree. It's something to sort through. On that note, are there pull requests that like need to be? Because I've certainly been not on top of things recently.
No, on my side, you've commented tons of stuff, so I just need to go through it.
Can I make a comment on that improvement potential field pull request actually?
Sure.
So we can have like, that's the one for example I had in mind. And, like we had the VRM one also for demo. So just for like the history of that pull request. So it started a long time ago, like as you see February 7. And at the beginning it was fairly small, like it was like 400 line and 90% of it was web-based. And I got the first review by Unity and like very quickly and was fine, and then I did the change for the review, and then it stayed for a long time, and nobody touched it for a while, and then I revived it, just make it up to date with master. And so it was still fairly small and got kind of like ready to go again for reviews, but didn't get review for a long time. And then so Don jumped in with your own thing, and it's called potential field improvement. So you added a lot of your own stuff on top of that. So I understand the thing, but I was like just to comment, like to see what we want, what we actually want to do with this type of pull request. Like we have something very small and that kind of like self-contained and ready to go, and then if you have somebody adding a lot of things on top of that, is that what, even if it's part of the same problem, is that what we want to do, or should that be a separate pull request? I don't know. I just want to raise that.
Yeah, you should have come in like there, but then after that, like we improve, discretize the new tree mesh came in, so now we need the stuff to patch it up, and then of course, we should have merged them there and then start a new one. But yeah.
This is where I think too we need to make better use of Slack And there's potentially, like, we could create a new channel or something like that if you guys want. But I think that, like, because Thibaut, to your point, the fact that it was ready, but it sort of fell off the radar, like, you need an avenue to push and say, this thing is done, can we get it in? Because often, like right now, there's 9 pull requests on SimPEG, all of varying, like, doneness. Well, and also of, like, this is done, this is in progress, and that's fine. But to make sure that it's communicated that, like, I'm happy with this thing. If you are, then let's get it in.
But I think that was not a problem for that request. Was more like, as Doug said, like it's manpower. Like it's remaining because maybe we can go at if you go at some comments later. Like I didn't use, like, obviously I use this the comments here, and from reviewers I got, okay, yeah, thanks for that. I'm gonna go through that in the next few days and just see what was to be. So it was more. I think it was more a problem of manpower at that point.
Yeah, but I think too, like, don't hesitate to post on Slack, hey, can somebody help review this? Because it doesn't have to be, like, it doesn't have to be myself or Ron. If somebody else, like, one of the things that's been kind of cool I'm on the Interact Slack, and basically anytime a new pull request is generated, they just throw a message, hey, is somebody willing to review this? And that then hopefully starts moving things. But I think a lot of that is a communication thing. And then ideally, like, even if there was, and this PR an example too, like, even if there was new stuff, we probably should have branched off with this, just got in what Thibaut fixed and then go. So in the future we can try and do that, but I totally appreciate that sometimes it just, like.
No, as I said, I don't know what would be the best strategy, but like with that pull request was kind of for me like an example of, like, that's not gonna work in the future.
No, I agree. Actually, okay, so then let's take a look here and on Dispertize. Okay, so these ones need reviews. So if anybody would like to jump in and start having a look at these, that would be awesome.
Yeah, I think maybe, I don't know what's been changed on master, but last time I think the VRM examples actually passed.
Should probably break on stuff.
Now it's breaking stuff.
But that's fine, right? Because we knew that.
Oh yeah, the only thing that was breaking was the time domain EM test timed out.
Okay.
That was.
The tree mesh passes? The tree mesh.
I went and fixed. I fixed all that stuff.
Oh, okay.
Yeah, and then here, if you don't mind, try and be just a little more descriptive here.
Oh, yeah.
Just because this, like, whatever is in your main comment thread is what we pulled for the release notes.
Yeah, I can do that after the meeting.
That sounds good. And then I think there were a couple on Dispertize, and I meant to get in touch with you, Mike. There's the one that you did, and I was just wondering if you wouldn't mind.
We'd probably stream thickness.
Stream thickness,
Yeah.
yes.
Yeah.
There's a couple of those that are quite stale. I was just wondering, like, this is awesome. I was just wondering if you wouldn't mind making an example so that people can see it in use.
Yeah, that should be, I think, I should mostly be able to pull stuff from a notebook or two that I have.
Yeah, ideally the example doesn't necessarily depend on SimPEG, so even just create, like, a Gaussian that you draw all the arrows from, or a sine or whatever with varying thickness. But yeah, that would be great. And then there's a couple here. I'll post on Slack and maybe ping and see if somebody's willing to review both of these. With this one, what was I doing? This I actually think that we should rethink, but for now is perhaps okay, just to allow the line color and thickness to be changed on the plot grid. I think the viewers actually need to be rewritten as more object-based things, but that's beyond the scope of this. And then here I was just trying to do better naming conventions for some of the rotations between cylindrical and Cartesian. So that's basically that. Cool. Any other things or any things, Joe, that you'd like to
Joe's
go over?
gone.
Joe's there. That's gone.
Oh.
Oh, good.
Sounds good.
Perfect. Okay. Thanks, everyone.